Okay, guys, now we start with Chapter 8, and in Chapter 8 we're starting to talk about similar polygons. Now, by similar polygons, what we mean are two figures, as you can see here, which have the same shape, but are not the same in their size. Okay? When you talk about a scale model, you're talking about a figure which is similar to the original. Okay? So when we're speaking of similarity, we're talking about two figures, in this case we're talking about two polygons, okay, which have the same shape, okay, but are not the same in size, okay? So, all right, and the similarity is the symbol here, the little wave that shows that they're similar, okay? Now, we're going to ask you, if they're similar in shape, what is it that determines their shape? If they're not, if they're similar, but the size is not the same, what must be the same? So we come up with the following, okay? Um, the corresponding angles have got to be congruent, okay? Now that is what determines the shape of the figure. So if all the angles of this polygon ABCD are congruent to the corresponding angles of this polygon QRST, then that's one condition which is yet to be satisfied for similarity. And what angles match up? Well, the name says it. The first here, A matches up with Q, B matches up with R, C with S, and D with T. So we're going to measure those. We're going to measure this angle at A. It ends up being 30 and a half. The corresponding measure of the angle at A would be the angle at Q. Okay? Now this seems to be spun around a little bit. That's fine. Okay? But the thing is, it is similar, okay? The shape is very much the same. One is an enlarged version of the other, one is a shrunken down version of the other, okay? So here we measure the angles at B, go for 152, okay? The angles at C are congruent, okay? So all my angles of the yellow polygon are congruent with the corresponding, and what is it that makes for the corresponding? Okay, the A with Q, B with R. The name says it all right here. Okay, they are congruent with the corresponding angles of the red polygon. Now, that is not sufficient to show that the figures are congruent or similar. Okay, we must also test the ratio of their sides. Okay, the ratio of their sides. Now, I'm going to ask, what is the side which corresponds with AB? Well, right over here it's QR. Okay? What is the side which corresponds with AD? Over here it's going to be QT. Okay? So AB corresponds with QR. Okay? AD, AD is going to correspond with QT. Okay? And we're going to measure those, and we're going to take the ratios of the corresponding sides. Okay, AB to QR has a ratio of 2. Okay, BC to RS has a ratio of 2. CD to ST has a ratio of 2, as does AB and QR have a ratio of 2. So there we find, okay, that all the corresponding sides are with a consistent ratio of 2. That consistent ratio is what we call a scale factor. Okay? That consistent ratio is what we call a scale factor, okay? And that is to say, okay, all the sides of the yellow polygon are exactly twice the size of the red. And therefore, if we add all the sides, okay, then we get the perimeter, okay? And we would find that the perimeters of these two figures have that same ratio because the perimeter is nothing more than the sum of the sides. So the perimeters are in the same ratio. Now, what do you think? Do you think the ratios are in the same ratio? I mean, do you think the areas are in the same ratio? Okay. This yellow polygon has sides which are twice as large as this. Okay. Let's consider, for your consideration, a square. Let's consider a square whose sides are 2 inches each. The area is 4. Let's consider another square, the sides which are 4 inches each. The area is 16. okay? Although the sides are twice as long, the area is 4 times as great. So the areas are going to be in the square of the scale factor. We'll look at that more later. Now we're going to pose some questions to you, okay? Are all rectangles similar? Are all rectangles similar? Here's the yellow rectangle. Here's another yellow rectangle, okay? How do we know whether they're similar? Well, we certainly have two things we consider when we're looking at similarity. Are all the corresponding angles congruent? And are the sides in a constant ratio? Are the sides in a constant ratio? Well, certainly all angles are 90, okay? However, just consider for a moment a rectangle here and a square, which is 4 by 4, okay? Not this one, but a 4 by 4. So they're not going to be in a consistent ratio, okay? They are not going to be in a consistent ratio, and we're going to show you, okay? All angles are congruent. This is not sufficient. All corresponding sides. So we look at the ratio of the corresponding sides, okay? So I have the ratio of GH, okay, to DA, all right? GH to to DA, that's a ratio of 3 to 5, which is 0.6. But if I look at the ratio of 4 to 9, that's a ratio of 0.44. So the sides are not in a consistent ratio. And therefore, okay, these two rectangles are not similar. And therefore, we conclude that not every two rectangles are going to be similar. Not every two rectangles are going to be similar. Let's throw some other questions out at you. Do you think that two squares are going to be similar? I would say they are. You think about it. Do you think our two rhombuses are going to be similar? Here's a rhombus here. Here's a rhombus here. This rhombus is a square, but it's also a rhombus. This is not a square. They don't even have the same shape. How could they be similar? Are all equilateral triangles similar? I'm going to venture to say yes. You should think the same, okay? Are all right triangles similar? Well, I do have, by Pythagoras, a 5, 12, 13 triangle, right triangle, but I also have a 3, 4, 5. I don't think we're going to have a consistent ratio of their corresponding sides there, so think twice about that. Are all 30, 60, 90 triangles similar? Are all 30, 60, 90 triangles similar? I'm going to venture to say yes. You should think about it, okay? Are all isosceles right triangles, that is, are all 45, 45, 90 right triangles similar? I'm going to go with affirmative on that. You should think about it as well. Are any two different regular pentagons similar? We know there's the same shape, but are the ratios of their sides going to be similar? I think they're going to say yes. Well, I can't say a regular pentagon is going to be similar to a regular hexagon, but I certainly can say any two regular pentagons are similar. Okay? Are all regular octagons similar? I'm going to respond affirmatively to that as well. Are all circles similar? All circles are similar. Okay? All right, so that is the beginning of Chapter 8, where we're talking about similar polygons, and as we showed here earlier, similar polygons have the same shape, but not necessarily the same size. The shape is dictated by the angles. The corresponding angles must always be congruent. This is the statement of similarity that we have up here. Okay? The corresponding sides must be proportional. Okay? From this statement here, we should know what angles correspond with the other angles and what sides correspond. Okay? And that's where we'll take it from here.